Hemisphere exam number 2 in 2021. So question number 1 is a parametric equation question. So I might have a little look at that. So I'm going over into graphs and tables. And I'm going to enter parametrically. So I change it from y equals to xt equals. And I get 2 lines per equation. And this is sec, which is 1 divided by cos. So 1 divided by cos of t, and in math 2 I find a t, close bracket, and the y value is cosec, so 1 divided by sine of t, close bracket, ticket, and in my window I start with the x's and then the y's, and the t's go from 0 to pi on 2, so if I come down I can see this goes from 0 to pi divided by 2. Okay, and now I can graph it and I can see what my graph looks like. And if I go maybe zoom out. Okay, so there's what the graph looks like. Okay, so I've got an idea of what it looks like when I need to graph it. I need to show that this gives me this. So x equals 1 on sine cos t. I'm going to move that around to cos t is 1 on x, therefore sine t is 1 on y. I wish to use the idea that cos squared plus sine squared is 1, so that gives me this. Rearrange, given what I was asked to rearrange. Part B, state the domain and range of y. Well, the domain will be the range of the x component, so the range of this, and the range of this will be 1 to infinity, because it's the reciprocal of cos, and the range of y will be the range of this here, which will be 1 on sine, so that's also 1 to infinity. Using derivatives, show that the gradient is always negative. So here is my chain of derivatives. So dy dt gives me this expression, dx dt gives me this expression using the derivative. Now, I want for the first quadrant, so quadrant 1, because t goes from 0 to pi on 2, this will always be negative, this will always be positive in the first quadrant because of the negative, and my dx dt in the first quadrant, that will always be positive, and that will always be positive. Therefore, I have dy dx is going to be negative because I've got this which will always be negative and this which will always be positive. Over the page I'm asked to draw it. Well, I've got an idea of what it looks like here. Asymptote at y equals 1, asymptote at x equals 1. And I've put in 2 points by working out what those coordinates are. Write down definite integral in terms of x, which gives you the arc length from 1.1, 1.5 through to 4. So we're looking for that arc length. So this is going to be my definite integral, which gives me this. Throw this on the calculator. Now my calculator didn't solve this. So I grabbed the inside and I graphed it. Then I found the integral from 1.5 to 4, and that gave me my 2.54, and that's question